Hello, hi, namaste. My name is Jivan Zuyuswal, and we just started a series about DSA with Java. And this is the first series in my YouTube. Okay, we just started with arrays concept. Inside the arrays concept, we just talk about how to declare, initialize, update, and some DDT operation inside the array. After that, we just talk about the searching concept. Inside the searching concept, we just talk about a binary search. Okay, a binary search. We already talked about there is two kind of searching are there. One is binary search, another one is our linear search. We just talk about our linear search, not binary search actually. So, we just talk about the two types of searching we just talk about that only. We just talk about first one we just completed, that is linear search, but there is another search is there which is known as binary search. Okay, we already covered our linear search, that's why we are going to cover our the second part, means the binary search. Okay, for the binary search, why we just go for the binary search? For the binary search there is some condition are there. One condition for the binary search is should be means the array should be sorted. Okay, we'll understand here what do you mean by sorted. Okay, first condition should be array should be sorted. Okay, array should be sorted. First condition, array should be sorted. And okay, what do you mean by sorted? Sorted array. Or just like just think it is my array. Let's consider it is a array. Let's consider 3 is there, 45 is here, 1 is here, and 0 is here, and 3 is here, 31 is here. Okay, it is a unsorted array, means elements are not present in sequential order. What do you mean by sequential order here? It can be from lower to higher or higher to lower, means it can follow the something like um, uh, uh, lower to higher, or just like something like this only. If it will be contain one, sorry, 0 is the lowest one, then 1, then 3 will be there, then 31 is here, and last one will be 45. Okay, 45. This is nothing but our a sorted array, and the value is something lower to higher order, and it can be also possible something like that only. Okay, I'm just decreasing the size. Okay, it can be something like that only. It can contain 45 first, after that 31, after that 3, after that 1, after that 0, or it can be something like an ascending or descending order. This is known as sorted order. Sorted order, this is a sorted order. Okay, this, okay, one second. This can be sorted order, or this can be a sorted order. This is nothing but our ascending order, this is nothing our descending order. Okay, but we always use this one, means our ascending order we are mostly use. That's why we are going to take a array which is just like a sorted array from which is follow the ascending order. That's why we are going to find an element here. Okay, let's take to another page. Here I am going to create a integer type of array, which is going to be a sorted array containing 2, 3 of 76, 90, 100. It will be here. Okay, I'm just increasing the size of the array, size of the test. Okay, not the size of the array actually. Okay, we are going to, we just declare an array, declare with initializing the array directly. Okay, our element is, we want to find an element, that is we want to find the element 76 here. Okay, if we want to find an element which is not present inside the array, then we have to print. Okay, our output should something like that only, -1. Okay, our output something like that only, -1, if the element is present. Okay, if the element is present, let's talk about 76. Okay, at that time only I just want to print the output as the index position. What is the index position here? Index position is 2. Okay, that is my motto, means that is our that should be our output. Okay, let's see it will be going to be something like that only or not. Okay, let's declare a element which is present inside the array. Firstly, we are declaring the 7 6 first. Okay. For this reason, okay, we have the element or we have the array, but for the linear search we just go randomly from 0 to n minus 1 position. But here we are not going to something like that only. That's why we are just going to declare a integer I is nothing but the index position 0, and another integer j is 0. Okay, not take I and j, let's take start, it will be going to index number 0, and let's take another, that will be end. It is going to be nothing but our index position length minus 1, means arrays dot length minus 1 position. Okay. We have an array and have an element, and we just declaring because we are using the binary search algorithm. Binary search algorithm something say like that only, if our array is present or if our element is present, we are going to return the index position. Okay, means actually what is the binary position motto? We already know linear search is you can use any kind of array for the sorted or unsorted array, but binary search we are using for the sorted array. Okay, let's talk about here. I want to find the element number 31. Okay, let's talk about I want to find the element number 31. How to find this element number 31? Okay, if I am going to start it from 0 to n minus 1, it will be taking extra 3 iteration. Okay, it is going to check with 0, then 1, then 3, then 31, then it will be going to return it is present. Okay, if you are going to from opposite, okay, also taking one iteration. Okay, it is also a less time consuming, but we are not talking about this array. Okay, we are always not talking about this array, there will be any random array. That's why we are not going to something like that only. What we have to do? Okay, let's, it is my 0th position and it is my last position. Okay, the common position in between is what? It is the size of the array is equal to 5. My size of the array is equal to 5, and what will be my middle position? It will be 0 to n minus 1, means 0 minus n minus 1 is 5 minus 1, nothing but 4. Okay, it will be some, okay, we have just do something like that only, means we have to minus with n it will be nothing but n minus 1. N minus 1 is 4, 5 minus 1 is equal to something 4. We have to subtract with the starting position. What is my starting position? It will be 0 with 2. We want to find the middle position. The answer will be 2. Okay, the index number 2 position, it will be referring. It is 0, it is 1, and it is 2 is it is referring. Okay, we just want to check whether this element is our, the position number 2 element is equal to our finding element or not. If it is present, if it is equal, then we have to return yes, this position is here, means we have to return the position number. Okay, if it is not present, okay, if it is not present, then we have to check. Okay, it is not present. Okay, whether if the position number 2, whatever the element inside the position number 2, our mid position, it is lesser or greater than the element which you are finding. If it is lesser than, means if it is lesser than this element, the mid position, then we have to shift it the last position up to, we have to shift it our last position up to mid minus 1 position. If our element is greater than the mid value, then we have to shift it our starting position from mid to mid plus 1 value. Okay, that is our motto. After that, it will be going to taking more less time. Okay, because we are just shifting the elements. Okay, we are shifting the positions. Okay, that will be something interesting. That's why we will be go to see what will the code will be written. Okay, that's why I am taking a starting value as 0 and I am taking an ending value as something means length minus 1 position. Okay, here we am going to use while loop. While loop, I am declaring my start is lesser than or equal to my end. Okay, at that time what I have to do? Okay, here I am going to first check if, okay, before that I will declare a mid value. Mid, okay, my mid is equal to nothing but my mid is nothing but just end minus start by 2, or plus we can do. Okay, just make it plus. We are just making plus by 2. Okay, okay, here we can do plus. okay, not minus actually, because if it will be 1 then it will be fine. Okay, we have to make plus. Okay, we have to taking the mid position by adding the first index and the means starting index and last index by 2. Okay, here we are going to do something like that only. Okay, by 2 we just get the mid value here. After getting our mid value, okay, first condition we have to check whether mine just element, what of the element I am finding, it is this element is equal to my rth position of mid. If it will be fine, then we are going to do something like that only. Okay, okay, now we are going to talk about the return statement. Okay, means some just think it will be inside a method. We are going to return the position what mid we are returning. Okay, if it is not there, then else if it is not there, then we have to check whether my element, whatever the element I am finding inside the array, it will be greater than, or not. If it will be greater than or equal to rh position, not equal to actually, okay, greater than rh position of mid, at that time we are going to do something. If my element is greater than mid position, okay, element is greater than my mid position, means my element is present after the mid position, then why I have to start in from the 0? Less my start should be mid plus 1. Okay, else if my element, whatever the element I want to find, if it is lesser than the rh position of mid, at that time if my element is lesser than the rh position of a mid position, means whatever the element present inside the mid position, if it is greater than the element whatever I want to find, at that time I just want to do one thing. We can do the ending point is equal to mid minus 1. Okay, uh, otherwise if all the conditions are not satisfied, then we are going to do something like that only. Just we are going to do returning the 0. Okay, if all the conditions are false, whereas here we are going to return minus 1, not 0, minus 1. Okay, why is returning minus 1? Can we elaborate why we are returning minus 1? Actually, the minus 1 position is not present inside the array, that's why we are returning minus 1. It is indication, nothing but we can just return any boolean value here. Okay, let's do this program inside our compiler. Here we already know we are using our online compiler. Okay, it is not sponsored, it is by programmers, you can use. Okay, okay, we're just going to talk about some. Okay, we always write our logic inside the main method. Today we are going to write our logic inside a method. Let's make a static. We don't want to create a necessary object for the class to calling the non-static method. That's why we're going to taking the static method. Static, we just want to return the integer type. Okay, and my array will be, means my method name will be binary. Okay, binary search. Okay, for the binary search, what we want here. Okay, inside here we just want the integer type array, and also whatever the element we want to find, and we want to find that element, that will be our, means that this thing are needed for us. Okay, just declare a integer type of array. Inside the integer type of array, just creating a integer type of array directly. That will be our a sorted array. Okay, 123, then 45, then be 56, then 90. Okay, just another element to just put 100. Okay, and that is an element here. We want to find our element 45. Okay, here we are just putting a condition. Okay, just you can just print system dot out dot print ln of, we just want to print our index position. Okay, because we already talked that if my array will means whatever the element will be present inside the array, at that time we will return the index value. If our element is not present, at that time we are returning the -1 value. Okay, here I am passing the array and my element. Okay, let's see. Here we are going to write our binary search logic. Okay, for the binary search logic we just want a int start is equal to 0. Okay, here I am just telling my n value is equal to array dot length -1. Okay, we are going to check with while loop. Inside the while loop we are going to write to end. At that time we are going to check int mid. My mid is nothing but my end plus start. Okay, and plus start by 2. Okay, first of all I have to check whether my whatever the element I am finding, it is equal to the position inside the mid position. If it is equal, at that time we are going to return our mid position. Okay, if it is not present, if my position is not present, okay, if it is not equal, then we are going to check on condition. If our element is less than array position of mid, if my element is lesser than the position mid, okay, if my element is lesser than the position page, then at the time I have to change the n value equal to mid minus 1. Else if my element present inside the array, if it is greater than my array of mid position, at that time I have to change my start position. My start equal to mid plus 1. Okay, otherwise if all the conditions are not going to satisfy, at that time I am going to return -1. Okay, let's check whether it is going to work fine. Okay, perfect. Okay, let's run. Okay, something error. Okay, ele what about the, okay, something mistake was done by me. Okay, let's see. Okay, line number 2. Okay, identify are required. Okay, one second, what about the, okay, something mistake inside the spelling, actually nothing error here. Okay, we just write public p. Okay, we just write c here. Okay, now it will be fine. Let's see. Okay, it is going to showing the index position. Okay, if let's try something, the in element, let's pass some element which is not present inside the array. Let's, it will be 200. Let's search the element. Okay, it is throwing the -1 as expected. Means why, if my element will be not there, it will be going to throw, it is going to give my output as -1. If there is the element is present inside that array, then at that time the element is going to give me the exit output for the index position. Okay, now let's do this program inside the GFG. Let's search for GFG. Okay, okay, and now we are going to see this problem inside our GFG. Okay, what this, okay, it's fine. Okay, it is nothing but our binary search algorithm. What we have to do, given a sorted array is here and the size of the array is bn, and we are passing an integer k, find the position, okay, we have to find the position where which k is present. K is nothing but our element. Okay, let's take a int start is nothing but our 0th value, and our int end nothing but our n is here na. Okay, n minus 1. Okay, we are going to put while whether my start is less than equal to n. At that time only I have to go for the mid value. Mid is equal to start plus end by 2. We have to give n by 2. Okay, here we are going to check if our k is nothing but our element is equal to our array of mid. If it will be there, here we are going to return the integer type. Okay, just return the position, mid is our position. Else if my k is less than array of mid, if my k value is lesser than the mid position, then I have to change my n value is equal to mid minus 1. Else if my k value is greater than array of mid, at that time I have to declare my start position is equal to mid plus 1. Otherwise I have to return minus 1. Okay, let's compile the program. Okay, okay, it's fine, it is working. Let's submit it. Yes, all the test cases are passing perfectly. Okay, one test case is there. Okay, it's fine, all the test cases are passed. Okay, this is all about the binary search. We can go through the questions and you can solve many other questions, something like that only. Okay, we will see you the next video. Thank you.